Hi, my name is Meghraj Goswami. My ID number is 2022A2B41869H, and in this video I'll be talking about the journey of a computer monitor. I'll be talking about the raw materials that have been used to manufacture it, how they have been sourced, and how they have been converted to useful components to manufacture the display. And I'll also touch upon how to reduce the materials that are used to construct the display, and also how to reuse and recycle the product and its components, that is the monitor and the components that have been used to make it. So computer monitor, it's a ubiquitous artifact of modern life. I'm certain you have seen a computer monitor. They're used in smartphones. Say it's a computer with a screen, so that's a computer monitor. Not exactly monitor, but a display. And advertisement boards, digital billboards, television sets. There are different technologies that have been used over time. So right now it's like LCD monitors with LED backlights. Before that it was cathode ray tubes based on CRT technology. So in this video I'll be focusing on the LCD displays. Okay, so I actually have a torn down kind of display with me. I have a Raspberry Pi. It's a single board computer, and I bought the display for using it as a web server and stuff. So I have a display with me. Here's the if you can see it, here's the electronic components. There are the circuit boards and ribbons and stuff. There are the switches, connectors, the HDMI port and all. And then here's the display. So it's a touchscreen display. So beneath this glass layer there's the layer that recognizes when you touch the display using electrical impulses. And yeah, that's something that I just wanted to show. I have a display lying around, a torn down display. So I'll be going through the raw materials now, and the raw materials that have been used to construct displays like this on a bigger scale. This is a smaller display. So tracing back to its raw materials, first up is glass. That's used for the outer surface of the display, and it should be smooth and durable. For example, if you have a touchscreen, not for even for laptops you have touchscreen monitors too. There's a layer beneath the glass layer which detects the touch and the coordinates based on electric impulses, and the glass layer is put on top of that, so it's like the final outer layer. There are different companies that make durable glass layers just for the purpose of displays. For example, speaking about mobiles, there's Corning's Gorilla Glass that's used. Liquid crystals, so these are organic compounds, artificially manufactured organic compounds that that are influenced by electric fields, and they allow certain particular lights in particular direction to pass, so polarized light to pass through, and that's an important mechanism of how displays work. The LED backlight, so that controls how the backlight of the pixels, the color it displays. So semiconductors are used like gallium arsenide and gallium phosphide. Plastic, it's also used a lot of places, and in case of monitors it's used for the outer casing and the outer framework of the monitor. Then there's metals, usually aluminum because it's lightweight and easily sourced than other metals, and it's used for the skeletal component, and also for the electronics like the integrated circuits and stuff, along with semiconductors for the circuitry and the heat reduction components and all. Then there's electronics. You have integrated circuit boards, you have transistors, capacitors, resistors, adhesives and sealants to put all of the components together. since sadly many manufacturers, what they do is they don't make their products repairable, just so that they kind of make it like a use once product, so that like their sales would be more. So instead of using repairable components, like having screws that end users could easily like remove, if in case a component stops working, they'll be able to remove it. But what manufacturers usually do is they use adhesives and sealants that like make sure that the not all of the manufacturers do this, but most of them do it. So they make sure that uh, yeah, it's kind of like a one-time use product. Then there's inorganic compounds. There's ITO. It's used for the transparent conductive coatings. First up is glass. So glass, as you know, is a brittle, transparent, non-crystalline solid. It's made by melting sand at in glass melting furnaces at around 1550 to 1600 degrees Celsius. And some other components, like in sand there's silicon dioxide, also found in quartz, and other components like soda lime is used for different type of glass. These are some of the components used. Glass is then formed by the molten sand or molten glass is it's called a floating process. So it's floated on a molten tin bed, and then it is annealed, which is to say that it is cooled, and it is laminated and cut into sheets, and that's how you get the glass that's used for making. So different manufacturers, different they make these glass sheets in bulk, and the companies buy them based on the like aspect ratio they want. And yes, then we have liquid crystals, the one of the main components in the like technology that's used for LCD displays. So yeah, liquid crystals are organic compounds, so they have both the properties of conventional liquids and also solid crystals. So yeah, the research was started by Richard Williams, as you can see, in 1962. Earlier, before this, the major display technology that was used was cathode ray tubes, and they were very bulky. And the research to use liquid crystals originally, like when it started in 1962, the liquid crystals, they couldn't be used at room temperature. So their operational temperature was, like, if I'm not wrong, about 115 degrees Celsius, and that obviously wouldn't have been a very practical solution for making like daily use household products, kind of like the superconductor situation now. Like, you have superconductors, but they don't there's no superconductor that performs well at like room temperature. So that was the situation back then with liquid crystals. But then as the research progressed, people made the liquid crystals that could that got influenced by electric fields, that like worked as liquid crystals in temperature ranges of like 20 degrees Celsius to 100 degrees Celsius, so within room temperature. And that's how the research was fueled, and newer display technologies were created. And now we have these thin, very thin displays, instead of having the bulky CRT tube, cathode ray tube based displays. Yeah, so liquid crystals are long rod shaped molecules. That's the chemistry part, and they change their orientation based on electric field. So in presence of an electric field, the liquid crystals, they get oriented in some way, and that's how they allow only light in a particular orientation or direction to pass. So that's called polarized light. Yeah, as you can see, polarized light passes through the liquid crystal. And there's plastic. So plastic, as I said, is used for making the external casing of the display, and usually the ABS, that is acrylonitrile butadiene styrene plastic, is used. That's because it's easily, wait, I'll go to the next point. Yeah, that's because it's easily moldable, it's very lightweight, and also durable, and has like, it's tough, so it doesn't crack easily, break easily, it doesn't fail easily, and it is impact resistance again, so it doesn't fail easily. And it is like easily moldable and has good, you can add good aesthetic surface finishes to it. For example, all the monitors you might have seen, like computer monitors, they have a plastic finishing, so that's usually ABS. and also they're resistant to inert to chemical cleaning agents. So plastic, the EVS, is obtained from crude oil and natural gas. So the crude oil, it's refined, and the refined oil is cracked. That is to say, the organic hydrocarbon compounds that are present in the refined oil, they are broken down into smaller compounds, smaller hydrocarbons, and then they are polymerized, which means that they are again joined together to form long polymers of plastic. So like multiple larger hydrocarbons are broken down into smaller components, then they're linked together, polymerized to form plastics. Then we have metal. So metal, as I said, the most commonly used metal is aluminium, just because it is very lightweight and easy to work with. It has good workability. It's lightweight and it's easier to source. So it's used for structural components, and not aluminium, but metals are also used in the integrated circuit boards and all the electronics for the display. So yeah, aluminum is commonly used, and it is obtained from the bauxite ore. So bauxite ore, it is obtained from like the quarries and mineries and stuff. Like it is mined and it is refined to form the alumina, which is aluminium oxide, using Bayer's process, and then it is converted to useful aluminium using Hall-Héroult process. So aluminium is lightweight, it is corrosion resistant, and it is also a good conductor of heat, which is important because monitors, the electronics and stuff, they get warm, no? So if the heat is not dissipated like equally and easily, then it will get problematic. There have been cases of like meltdowns and all. So it a good heat sink and like heat dissipating technology has to be used. So yeah, aluminum metal is also used as heat sinks, and they are pretty good at dissipating heat, along with copper. Copper is also used. Right, so now we get to the reduction of raw materials part. So new research has been going on and is still going on in like semiconductors and materials for the making the display. For example, the liquid crystals. New research has been going on semiconductors for the electronic components to make them more energy efficient, and that way like a lower amount of materials will have to be used to create the same product. So lower amount of materials will be used, and nowadays components like speakers and power supplies, they're already integrated in the monitor, so people don't have to go out and buy the components separately, and not as much components have to be manufactured otherwise. They're already integrated, and so because of that integrated process, lesser materials are used, and having a streamlined design process is important, which companies are moving towards. So a streamlined design process also leads in reduction of the materials that are used. Right, so we now talk about reusing the components and the product. So repurposing old displays in innovative ways. For example, you can set up old displays as photo frames, digital photo frames, smart mirrors. Like you can basically, instead of throwing them away, or you can repurpose them, give them new life. You can use them as your car's entertainment system, or yeah, like possibilities are endless, but you can repurpose old displays if they're in any capacity, like any working condition, any capacity of working. Then you have modular designs for displays. So framework, it's not exactly a like display company, but I want to talk about the company. Framework is it primarily manufactures laptops. They are famous for having a modular design. So what they do is, instead of like traditional manufacturers, instead of putting like in laptops, gluing all the things together and making them not as much repairable, consumer friendly, what framework does it, they make everything modular. So in case you want to change out, for example, you want to change out your display's bezel, you unscrew the bezels, put on a new bezel. If your display has dead pixels and you want to switch it out for a new display, you take out the display, you recycle it. They have a separate process for that, and you buy a new display and you put it in your laptop. So even for computer monitors, it has lots of components, and a good way of reusing like reusing old components, working components, and not like throwing the display away in case some component stops working, is having modular design. Then salvaging components. So monitors, for example, they, as I talked, the raw materials that they have are plastic, metals, especially for like the connectors in the ports and all. Gold in some small quantity is used for like higher end products, because because of connectivity and all. So gold is used in the like ends of the connectors, and that is a valuable material, and other chemicals and stuff too. So if you had have thrown the display away, it might have been hazardous, like it's usually shipped to landfills and all, and there it's usually burned. So the chemicals there have polluted the environment and posed risk to the like local life and the environment. So instead of that, the components, the smaller components and even larger, like the power supply and all, they can be salvaged, the speakers, power supplies, and that's how the product or its components can be reused. Recycled, the product can be recycled using exchange programs. So when you try to buy a new device or screen or anything like technology wise on Amazon, say, they have a program where you can exchange an existing device. Like not just Amazon, I'm just giving an example, but lots of companies and organizations have this thing where you can exchange your older, like current product for a new one. And once you give them your old product, they recycle it, or they open it up and reuse the components. So yeah, that's how you can ensure that your product is not going to waste like landfills and stuff, and it's actually being recycled. Components, like you can open up the components and, like for example, the casing and stuff, and you can recycle them separately. There are organizations that take the components, or even like I have added a point for buyback later. Yeah, manufacturer buyback. So what manufacturers do is they once your product has reached its end of life, instead of throwing it away, manufacturers incentivize you to return the product, so that they can use it. They can get the product back and use whatever's working, whatever's left. Apple does it a lot. They have whole factory set up to like squeeze the life out of whatever life is left out of old and discarded products, and then use them, recycle them and use them in the newer products. And donations and sale, like you, instead of holding or throwing away displays, you can just like donate older displays and sell them, technically recycling them, like you're recycling the displays. And yeah, that's it. Thank you for watching.